In this tutorial video we're going to have a look at some transformations of functions. This is going to develop on our previous video, an introduction to transformations of functions, and we're going to be using some of the techniques that we'll learn in that particular video. If it's an introduction you want, you should go to our other video which is called Introduction to the Transformation of Functions. So moving on, this question says the curve y equals 5 root x is transformed by a stretch, scale factor half, parallel to the x-axis. Find the equation of the curve after it's been transformed. I always find it helps to write this in function notation first of all. So f of x equals 5 root x, and we're trying to transform that function to get a new one. Well, the first thing I notice is that it's parallel to the x-axis, so I know any transformation I'm going to perform has to be on the inside, and if it's on the inside it does the opposite. So if I stretch by scale factor 1/2, I times all the x values by 1/2. In order to achieve that on the inside of a function, I do the opposite, which is timesing by 2. Okay, so f of 2x, I'm replacing all the x's with 2x's to give 5 root of 2x. So writing it out in the format required, y equals 5 root of 2x. So what I've done here, that's a stretch because I've times by a number, scale factor 1/2 because it's inside and does the opposite, parallel to the x-axis. So there's the answer there. Part 2, describe the single transformation which transforms the curve y equals 5 root x to the curve 5 root of x minus 3. Well, I can see there that we've taken 3 on the outside of the function, so it's a y direction, and taking is a translate. So translate minus 3 in the y direction, so not in the x direction, minus 3, because outside transformations do what they say to the y values. So that's that question done. Let's have a look at another one now. Let's have a look at this question here. So in this particular question, we can see that it's asking us to sketch the curve of y equals x cubed. So what we should use for these types of question is a ruler and a pencil. Ruler because we want it to be presentable, and a pencil because if you get it wrong, you want to be able to rub it out and do it again. If you do it in pen, obviously that's not possible. Okay, so the features of an x cubed graph that get the marks. The graph should start almost but not quite vertical, and gradually get less and less steep as you get towards the origin. However, at the origin we need to have a stationary point. It needs to be flat, gradient 0. There it is there, and it needs to get steeper and steeper and steeper, but not quite get vertical. So y equals x cubed, and they're the features that will get it marks. Things that would lose marks if it curls back on itself, if that's not flat at the middle, or if it goes vertical, or if these end up straight lines. They're things that you can't do, they're things that will lose marks. So this is question 2 part 1. 2 part 2. Describe a transformation that transforms the curve y equals x cubed to y equals minus x cubed. Well, what we've done in this one, we've attached a minus sign on the outside of the function. So attaching a minus sign, as we saw from our previous video, that's a reflection, so we're going to reflect it, and we're reflecting it because it's on the outside in the y direction. So a reflection in the y direction reflects through the x-axis, so reflect through x-axis. However, a small technical point, if you wrote reflect through y-axis, in this particular case you'd have got the marks, because also this curve is equivalent if we treat it as an inside transformation. And looking at the graph, convince yourself of it, if we reflect it through the y-axis, it's going to give exactly the same curve as if you reflect it through the x-axis, so both in this case are acceptable. Part 3. The curve y equals x cubed is translated p units parallel to the x-axis. I can instantly see that this is parallel to the x-axis, so it's going to have to be inside. So we start with f of x, and parallel to the x-axis means it's going to be inside. We want to translate positive p units, so on the inside it does the opposite. We know better, we have to take p on the inside to achieve that. Therefore, we're going to replace the x's with x minus p's, which means that the new curve is going to be y equals, and replace x with x minus p, so it's now x minus p, we're cubing. And that's all of the marks. For more resources like this, subscribe to our YouTube channel or go to alevelmathsrevision.com.